Is the volume okay? Okay. My name is John Dowling. I'm with Mantech International, and I'm here to open the panel discussion today for emerging technologies within the DISA Directorate. So if you would welcome me or help me welcome our panel guests today. So first we have Mr. Steve Wallace, Chief Technology Officer and Director for Emergency Technologies Directorate.
Thank you, sir.
Next up, Mr. Bill Grenzer, Technical Director for Emergency Technologies. Next up, Mr. Eric Malott, Senior Technical Strategist for DISA and a highly qualified expert. Next up, Mr. Cameron Rahman, Senior NG 5G Lead for Emerging Technologies. All right, and last but not least, Mr. Deepak Seth, Technical Lead for Emerging Technologies. I'll turn it over to Steve.
All right. Thanks, John. Yes, sir. All right, so I see they put us near the desserts, so we'll have about 15 minutes with you all before you're nodding off, but we'll make the most of it. All right, so we decided this year to throw a little bit of a panel together. So you already got the intros for our folks here. Let's see. I got to bring up our Tuesday. Sorry, give me one second. There we go. Let's bring up our slides. Because it wouldn't be a good government meeting without PowerPoint, right? All right, so we're going to talk to you about some of the technology trends that we're seeing in the department across the agency. So with that, I'm going to flip here. Got to have the obligatory disclaimer. I'm sure you've all read it, memorized it, and can repeat it. We introed our panel already. Look at those lovely faces there. And so we're going to start with, wow, that got a little jacked up in the transition. But so we're going to start with our tech watch list. So Bill's going to talk to you a little bit about the background of our tech watch list. Many of you have probably seen it before. But with that, Bill, I'll hand it over to you for a little intro.
Yeah, absolutely. Thanks, Steve. So, like Steve said, you've probably seen our tech watch list slide before, but just as an introduction for those of you who haven't seen it, it's just a way to visualize all the technical areas that this is going to be looking at over the coming 12 months or even several years out. Right. So as you look at the slide, the way it's set up is if you start in the outer ring there, the monitor ring. So those technologies are brand new to us. They're probably several years out from deployment, and the state that we're in is we're trying to wrap our head around the technology and get a better understanding of the state of industry on that side. And like I said, several years out from deployment. As you start to move towards the center in the planning phase, in that phase we're more comfortable with the technology and the state of maturity there, and we're likely looking for resources around DISA and where it might live when we do get to a prototype or a deployment. And then as you move to the prototype phase, that one's pretty self-explanatory, right? So we've either got a pilot going, or maybe we've done an OTA for those specific technologies, and we're getting closer to deployment. And then obviously deployment; those are technologies that we're likely going to deploy within the next 12 months. And the way we've set up the bullets that you see there, as you go, and like Steve said, it got a little messed up in transition, but the wedges as you go across the half circle there are the lines of effort from our strategic plan, and let me show off that I actually know what they are, right? So LOE1 is C2, LOE2 is innovation, LOE3 is data, LOE4 is user experience, and LOE5 is empowering the workforce. So with all that being said, what we're going to do now is Eric and I are going to kind of go back and forth through some of the newer items on the tech watch list. Eric, you want to kick it off?
Yeah, thanks, Bill. Yes, so of the tech watch list items, one we're going to start with is composable security architecture. So in that particular area, what we're looking for is that, with the various diverse ecosystem of security and networking, equipment and ability to put policy out there, as we extend our capabilities beyond our on-premise onto where our end user devices are, onto where the cloud, into like where tactical and edge situations, we're looking to sort of simplify the generation of security policy enabled to deploy that across a very diverse ecosystem of security components, vendor products, if you will. We're sort of following, there's been an open source sort of framework being endorsed by some of the vendors out there in the community. It's the Open Cybersecurity Schema framework. So it's a framework, if you will, on how to get telemetry and log data from security devices and being able to generate policy, if you will, that we would like to use to be able to more easily deploy security configurations, reactions to incidents, things like that, additional controls to be able to deploy that out across our very diverse ecosystem. Like I said, whether that's going to extend to cloud, on-premise, into the end-user device environments, that's sort of what we're looking for with that type of capability. And it's sort of new from what we understand from the industry perspective. So we're looking for ideas. We're looking for sort of implementations, some of those schemas, if you will, to where we can come in and start to prototype and pilot some of these capabilities and see how the technologies align to our infrastructure, if you will.
All right. So the next one we're going to talk about is XDR, or extended detection and response, right? So that technology kind of takes the traditional threat detection and incident response capabilities that we're familiar with from EDR or endpoint detection and response, and kind of expands that out to a broader environment, right? So from traditional endpoints to network devices, to cloud workloads, to servers, et cetera, right? So what we're really looking at here is integrating the disparate set of solutions and tools that we use today for threat detection on those devices, and really giving ourselves a central management platform where we can, like I said, manage, monitor, alerts, and respond to incidents. And kind of like we talk about with composable security architecture, one of the main drivers here is the development of APIs and open standards to allow all of those disparate tool sets to kind of talk to that central management platform. And where we are today is our team in emerging technologies has kind of started with first cataloging the tools that DISA is using today, and then using that to develop a market study to kind of look at across the vendor space, how close we are to being able to actually deploy a technology in this space. We've talked with a number of vendors out here on the floor today already that have XDR capabilities. So if we haven't talked to you yet, we're certainly looking to engage.
Just to add to what Bill said in the XDR space, so there's also a AI component to it. So the question really becomes is how do we use data to an advantage? So we're collecting all this data. There's all this telemetry. So the question really becomes is how can we use AI to process all this data and then be able to detect threats that we don't know about. So that's another area as part of XDR that we're looking at.
Absolutely.
Okay. Yeah, moving along, staying in the security theme, if you will. Another one we're going to highlight is the autonomous pen testing. So What we're looking at here in this arena is trying to automate a lot of the functions that we would typically see a team of pen testers would do for us within the agency. Those resources are becoming more and more limited, if you will, being able to have a team of highly skilled pen testers. We're looking to figure out ways in which we can leverage technology to do automation, continuous validation, if you will, doing that vulnerability assessment and doing that penetration testing based on, and two, enabling that with AI, with being able to bring in artificial intelligence to be able to think like a hacker, if you will, to be able to do some of those test scenarios where we can start to go out and assess our environments and be able to do in a more regular basis that penetration testing. So that's what we're looking to do with that.
So next item is IoT security and defense, and I think we've seen an explosion over the last several years of devices, whether it be on DoD networks or on the internet at large, that don't fit into the traditional definition of what we would call an endpoint, right? So these IoT devices, there's a lot of concern there about how do we secure these devices, and we're looking at it from a number of different perspectives. I think 3 different perspectives, right? So first, I think we need to do a better job of categorizing that IoT traffic, right? So whether it's at the boundary of our network or somewhere closer in on our network, once we categorize the traffic, then we can do a better job of writing rule sets specifically for that IoT traffic. And then second, as we get closer to those IoT devices, if we have an enclave of devices, a smaller enclave, potentially we can put an additional security solution in front of that enclave specifically for securing that IoT enclave. And then as we get onto the IoT device itself, we've seen a huge number of vulnerabilities over the last 5 years or so, whether it be on the iOS or on the OS on those devices or firmware, right? So how do we secure those devices themselves? And kind of where we are today, again, our team in EM has done a pretty expansive market study on all 3 levels that I just talked about right there, and we have some vendor devices in our lab environment today, as far as a hardware solution for securing that enclave that I talked about. So that's where we are today.
Next up, I'm going to talk about API security and a registry. So as we start to see more interfaces being opened up across the agency, across the department, as integrators and developers are building systems and solutions and trying to, what we'd like to do is minimize the amount of recreating of systems out there and be able to open up the access to systems via APIs more widely by having a registry potentially for DISA and the rest of the DoD of available APIs across the department that are integrated with various systems and applications. One would be, so that's our first prong, if you will, is to have that registry to be able to catalog all those services and make them available, be able to tell users, if you will, how to interface, how to authenticate, things of that nature. And then from the security perspective, API security is very much something that we're interested in being able to bring into the agency, bring into our application environments to be able to authenticate, validate, inspect those transactions that are going on at the API level. We're looking for technologies to be able to bring in with our security solutions. Again, whether it's with Thunderdome or with our on-prem or cloud, we're bringing in those, looking for capabilities there for overall API security. So if you're in that space, if you're developing those types of products, we'd be interested in certainly talking to you and bringing in those types of capabilities.
So next item we're going to talk about is edge computing, right? So I think, over the last decade or even further back, whether it's traditional on-prem data center workloads or as we've transitioned to cloud workloads, I think we've all seen the benefits of centralizing our workloads and the efficiencies there. But kind of like I talked about with IoT devices, we're seeing a large increase in devices that are completing their computing out closer to the edge, right? And that brings up a number of issues for us, right? Because most of those devices, yes, they're doing some computing on board out at the edge, but many have to also phone home, whether it be for management, logging, those kinds of things, right? So it brings up a number of concerns for us, which would be one, in a DDIL type of environment, how do we ensure that communication or the phone home actually happens? Because a lot of these devices are completing, increasingly critical workloads, right? And then from the other side of it, in a DDIL environment, how do we ensure that cloud workloads are making it through to the edge? So how do we move those cloud workloads closer to the edge when necessary, right? So that's edge computing, and I'm going to give you one bonus item, but before I give up the microphone. And you won't see it on our technology watch list, but I think it would actually fall under classified mobile capabilities. So just recently, our office in emerging technologies issued an OTA for our next generation WinDAR capability. That's our remote access to SIPR from a traditional laptop form factor. And so we're just getting started with that. And while we were developing the requirements for that OTA, several of our mission partners came to us with a requirement for a multi-level device. And we didn't think that we could fit that into the requirement set for our OTA, but we thought what we could do is utilize an Access CDS, and so that's what I want to talk about, right? So the requirement here is, can we use an Access CDS to give our users on SIPR a browse down capability to NIPRNet, right? So, and where we are with that today is our team has an Access CDS device in our laboratory environment, and it's really new to us. We're looking at how do we configure it, how do we manage it, and how would it fit into our architecture as we deploy. But we're really looking to move quickly with this so that we can match up to the timeline of our OTA and deploy alongside that, right? So like I said, we're moving quickly and we've just started. So if you're a vendor out there that either has a solution or has experience as an integrator with an Access CDS type of capability, we would love to engage with you.
All right, thanks guys. So hopefully everybody saw General Skinner's address at the keynote earlier. If you didn't, the first 30 seconds or so, he opened the presentation with a generative AI-based script. So Deepak and his team have for some time now, a few months, been looking at a number of generative AI capabilities. And we sat down with the director one day and we said, hey boss, look at what we're doing here. It's pretty interesting, the things that we're able to get out of it, the way that we're training the model. Showed him what happens if you inject bad data into the system, how it can cause the system to hallucinate and give you poor results. And then on top of that, the audio that you heard as he started there was through a voice cloning piece of software that we found. Frankly, all the voice cloning we did for free. It took about 30 minutes of training data, and then we were able to, the actual original audio that we were going to open up with was about 2 minutes in length. It was pretty wild. I actually called him one day and played his own voice for him, generated some content and played it back to him, and it was a little spooky. But Deepak, lots of buzz. Obviously the director opened up with it. You can't open up a tech rag these days without seeing something about generative AI. There's a few, competing solutions out there. The big names, Bard, ChatGPT, are sort of the Kleenex brands, if you will. But can you talk to us a little bit about what these generative AI platforms are doing?
Yeah. So one of these generative platforms is ChatGPT. So ChatGPT is what's called a large language model. It has the ability to generate human-like responses to a wide variety of questions and prompts. And there are many who have really praised these capabilities of ChatGPT and other generative AI technologies as a major breakthrough in artificial intelligence.
So as we started to put together the speech, can you talk a little bit more about, in total, I think it was supposed to go somewhere in the order of 2 minutes. 2 minutes and 30 seconds was the entire script that you all generated. Can you talk a little bit about the iterations that you all used and frankly, I'm not going to say simple, but how relatively straightforward it was to actually generate real content?
Yeah. So just full disclosure, everything I said up to now was generated by ChatGPT. So I went into ChatGPT, asked it a question, what is generative AI, and it gave me the response. So, I mean, to me this is pretty cool. I mean, you ask it a question and you get a response. So it sort of reminds me of the early days of the internet. I mean, never has such a advanced technology been so easily available. And the way I look at it is, how do we take this, so we can take this low code, no code approach to really, bring down the barriers to adopt AI at scale. So now regarding some of the speech, we were able to use ChatGPT. So one of using this whole low code, no code approach is that these large language models have APIs. So essentially what we did was to generate parts of the text of the speech is that we gave it examples of past speeches, and then we gave it some information about technology areas that either the large language model is unfamiliar with. And then we worked with the Microsoft team and got an instance of ChatGPT in the Azure cloud. And then after a couple of iterations going back and forth, and then the key thing was asking the right kind of question on the prompt. And going back and forth, we were able to get some text that sounded pretty good. And then, while we're going through these iterations, we even ask it, can you write a joke for us? And can you actually compare, football to cybersecurity? And I was pretty amazed. It actually came up with the Hail Mary pass analogy.
Yeah.
And it really said that, in the world of cybersecurity, we can't afford to rely on such risky Hail Mary passes. So I thought it was pretty cool going back and forth, working with the team, the type of content we're able to get.
It was actually pretty impressive the way that it did it. And a lot of the LLMs are evolving at different paces and have different specialties, if you will. So let's talk about other, LLMs are the big news right now, or generative AI. Where, we've been working with a number of AI initiatives between us, the JAIC, DARPA. Can you talk a little bit about some of the AI work that we have going on elsewhere?
Yeah, so another area that we're focusing our AI efforts is in the area of DCO, Defensive Cyber Operations. So several years back, we established a partnership with the JAIC, the Joint Artificial Intelligence Center, now known as the CDAO. And we're able to take advantage of the investments that the department has made in cloud, as well as AI. And our goal really here for AI and applying it towards DCO is really how do we detect anomalies on the network? And then more importantly, how do we shorten the time it takes our analysts to detect nefarious activity? So, as you all know, the speed and sophistication of attacks on our networks is increasing, but, we're also collecting a large amounts of data. So the question is, how can we really turn all this data, to an advantage? And that's where I believe, AI can really help. It can really help us, massively scale our ability to process all this data and to be able to detect and discern some of these, malicious activities that, the human eye or the analyst cannot spot. So our objective of this is that, we want to be able to pass all this data to some type of an AI system, and then, pass that output, onto the analyst so we can, augment the analyst with extra information that they may not have or they can find quicker. We're also very recently started working with DARPA on the CHASE program, so we're looking to see how can we bring in systems like CHASE, and also if there are other commercial systems, we're also very interested to hear about how can we again process all this data, shorten the time to detect anomalies, and make the life easier for our analysts.
All right, thanks, Deepak. So switching gears a little bit, one of the other areas of great interest for us, and we recently did an OTA, but as like most things, that's not the end. quantum resistant cryptography is a big area of interest for us, right? DISA is the deputy program manager for crypto for the entire department, right? Where we run the certificate authorities for the entire department. And if you're not watching what is going on in the world of quantum computing, it's pretty fascinating. A few of us had an opportunity a few weeks back to go to New York and actually see some quantum computing in action. It was very impressive, especially to talk to the men and women that are behind the capabilities that are growing it, and having them talk to us about the leaps and bounds year by year that they're growing. Last year, I think it was one of their quantum machines. I think it was good for, what was it, about 200 qubits, and the traditional compute, which tends to run alongside, was taking up an entire rack of gear. The expectation by next year is that they'll be at about 1,400 qubits, and right now, even today, they're down to a half rack of gear, potentially going smaller from there. It's still a bit unclear where quantum starts to intersect and starts to cause a problem for traditional crypto. The expectation is about at the 10,000 qubit mark, but nobody knows exactly for sure. And so, given the amount of time that it takes the department to roll to new crypto algorithms, we set out to frankly learn, right? So typically when we release an OTA, there is an expectation that we're rolling a capability into production. With this one, it's more about a learning opportunity. And so with that, I'm going to go back to Deepak. And Deepak, can you talk a little bit more about the threats that quantum machines sort of pose to your traditional and sort of where we're seeing some of the industry go?
Sure, Steve. So you talked about a qubit. So if we look at classical computers, they store information as a binary digit, bit 0 or 1. But in the case of quantum computers, it's a qubit. So it's 0, 1, 0 and 1 simultaneously. So all this, all this information can be stored in these qubits. And what that does is it creates a unprecedented amount of computing power. And what this computing power can do is it can act, so all these quantum computers can basically be used as a platform for nefarious activity. So there are a lot of benefits, and I think a lot of the benefits are still unknown as to what they can do. But the concern that we have is frankly that the term that's used is a cryptonatically relevant quantum computer. So when a quantum computer is able to break RSA, all the encryption that we rely on, whether it's on our CACs, our certificate authorities, all that could be impacted. And the problem is that it would really render insecure RSA, and then all the web protocols that use RSA, whether it's TLS or it's SSL, all those algorithms really underpin our public key infrastructure. So pretty much all the security that we rely on basically could be rendered insecure. Let me just give you an example. So there are many IT functions that we just take for granted. For example, when we want to navigate to a website, we want to conduct e-commerce, we want to authenticate using our CAP to an application. We send someone an encrypted email. We digitally sign a document. All the security of that could really be impacted. So we're really concerned that the security that we have by asymmetric cryptography that underpins all this could be impacted. And one other piece I also want to add is that we're also presuming that our adversaries are executing these so-called store now and decrypt later attacks. So we just assume, hey, our information is encrypted, it's going to be safe, but imagine if all that information could be stored, and in a couple of years, 5, 10, 15, doesn't really matter, all that information could be decrypted into the future. So we're sort of concerned about the problems that come from quantum computers.
It really does feel, and I'm dating myself, but it really does feel like the late 90s all over again, right? Many of us had mullets back then, but we were all looking for, what was about to happen in 1999 as the date clicked over, right? But there you had a point on a calendar that you could look at and say, that's what's coming for us. With something like this, there is no definitive date on a calendar. There is just the potential threat that lies out there that by the time that it happens, you're about 5 to 7 years too late in dealing with the issue.
And I think in addition to that, some of our adversaries right now are getting what classified or encrypted data they can and just holding it, right, and waiting for
the store and
and waiting for the quantum computing to come along, right? So yeah, we need to accelerate the shift to quantum resistant cryptography, even ahead of that, right?
So do you want to talk a little, Deepak, about the OTA that we did and potentially what we're trying to accomplish there, but then opportunities potentially after that, like it's not the end all be all, but what's it intended to teach us?
Yeah, so that's a good question. So we're basically just getting started. So basically to address some of these problems, we're working very closely with NIST. So last summer, NIST announced new cryptographic algorithms. So they, that can basically withstand attacks both from quantum computers as well as classical computers. So they announced Crystal Kybers for key management and the new Crystal's dilithium algorithm for digital signatures. So what we are looking to do is to begin prototyping some of these algorithms, and the main purpose of this is initially twofold. The first is, how do we incorporate these new algorithms as well as future algorithms into the IT systems and networks that we currently operate? And then secondly, we really want to understand what is the performance impact and computational overhead of these algorithms. So initially we're focusing on asymmetric cryptography. That's really our PKI infrastructure. But we're also beginning to look at, in addition to this, what this was focused on, but in the future, how do we better secure our optical backbone transport network? How can we safely distribute keys to some of the devices, but distribute these keys in a secure manner? So we're just beginning to look at what the impact is, but we also welcome any other ideas that you all have that that where we should really be focused on beyond PKI and beyond beyond securing our optical backbone network.
Thanks. So poor Cameron has sat here quietly and patiently for the last half hour, a little over half hour. So Cameron leads a lot of our 5G work. When EM came together a few years back, and actually Cameron came as part of the mobility team that came into the group. At that time, a lot of the Super Bowl commercials around 5G came out. It was 5G, 5G, 5G.
Correct.
And I will tell you that I was one of the ones sitting there going, okay, it's faster. Everybody asked, how are you going to use 5G? How's the department going to use 5G? And we were seeing a lot of hype. There wasn't a ton of action at that point. I've talked to many of you in the audience about it, and you have helped me along, frankly. And Cameron has patiently sat there poking me, and then then Courtney over there came to the table and pushed me over the edge, not literally, figuratively. But really, we were issued a task as part of the NDAA, which you can talk more about.
Sure.
About how we were going to monitor 5G networks, and the team has done a very good job at starting to build out and put together that story of how DISA can support that within the department. So Cameron, can you talk a little bit about how 5G is different than 4G? Where do we see it going? And I'll, before I steal any more thunder, have at it, buddy.
Sure. So I just want to say that, I've been in this industry for almost like 20 odd years. So to me, 4G, 5G is my forte. So to add this to all, I think 5G can solve almost all the problems. So
so we don't need zero trust or AI, and
if you just add another flavor on top of it, so I think it can solve some of these
I have a
security
box
problems.
at home that's my zero trust box, and it's 5G enabled.
Yes, sir. So we are actually applying zero trust also within our 3GPP standard. So we're actually looking into it, but it'll be a part of the 100 Dome if that makes you happy, sir. So as far as the 4G, 3G, this has been transitioning for 20 or so odd years. So people always tend to ask, okay, so what's new now? So again, now we have 5G. So basically, where we are heading with 5G is like immense amount of speeds. It's based on the enhanced mobile broadband. For 4G, what we had initially that we had at the user end about 10 megabits. Now we are approaching about 100 megabits per end user. But on the transport side, I mean, that increases quite a bit. I mean, as you know, for 4G, even it was being launched, there was about 1 gigabit on the transport side, but with 5G, it goes all the way to 20 gigs. So this immense speed brings a lot of challenges. I mean, how we're actually going to achieve all that. So there's quite a bit of work and effort going on this side. So what this new flavor that 5G brings is from consumer shift to an enterprise shift. So if you say enterprise shift, what exactly is it? So it's actually a private network for consumer-based services and commercial-based services to create some kind of a private enclave to provide high bandwidth speeds, ultra reliability, and how is this all provided? So there has been some changes within the 5G infrastructures and within the 3GPP standards to provide all this high speeds and ultra reliability. And on top of that, there's a lot of effort going on from machine communication, machine to machine communication. It's a part of the IoT as well. So I don't want to steal all the IoT functions, but within 3GPP, there's a talk about IoT as well. So what exactly is IoT within 3GPP? So all these commercial nodes that have been deployed outside on public safety, vehicle-to-vehicle communication, that's been on the consumer side. But getting back on the mission partner, so we are applying all these commercial side application and to see how these requirements can be met on the mission partner side. So there's quite a bit of an effort, and I don't think I can add on this within 5 minutes. There's quite a bit of an effort going on the OUSD R&D side of it. And there's an NDAA, which is the National Defense Authorization Act, which has actually asked HISA to provide continuous monitoring capability for all these private 5G nodes, and that's where we are at this point.
So can you talk to us about some of the use cases that we're seeing within the department? And then how will they be enabled on the infrastructure side, right? So how are we looking, and to be frank, one of my initial pushbacks was we're not going to be running a bunch of radio towers, right? That is not the traditional business that DISA is in. But can you talk to us about some of the use cases?
Yeah, sure. I think between me and Steve, I think I was always trying to convince Steve that 5G is something special. But so it took quite a bit of hard work convincing that it's not just the transport. There's quite a bit of intelligence embedded within the 5G, and it can do much more stuff that's actually perceived. So as far as what are the key enablers, there's quite a bit of work, as you know, has been done on this side of cloud, on the side of SDN, and on the side of edge computing. So all these capabilities which are already present on the IP side has been harnessed within 3GPP. So within 3GPP standards, there's also talk about pushing this core capability, which is actually centralized within the switch. So how do we provide ultra reliability capability? So there's a component called MEC within 3GPP standard that we're pushing it towards the edge of the site, so we can provide ultra reliability capability with that. And there's, of course, a network function of virtualization, which is based on the cloud infrastructure. So all this on-prem infrastructure that we have has actually been now virtualized. All the Ericssons and the Nokia are moving towards a virtualized function. And of course, we have container. And with opening up the stack, also there are some security concerns as well. So that's all up in the works. But it's all good. So we're advancing towards faster capability and a capability where all devices are going to be connected.
So, so on the commercial carrier side, right, we went from no data, 2G, 3G, 4G. Some carriers might have exaggerated a little bit and said 5GE, but 5G. It's been really a natural progression, and the main outcome for the consumer has been higher speeds, clearer call quality, those sorts of things. So, what's the specific importance to the U.S. government?
Okay, so that's actually a good question. I think for mission partners and the U.S. government, there has to be a specific requirements that we are actually working on. I mean, as you know, on the consumer side, the requirements are kind of different, but to meet our mission partner expectation, there's quite a bit of effort going on within the cross-functional team, which is actually headed by DoD CIO and the OUSD and R&D. So what's going on is that we are collecting all these requirements for various mission partners, and there's quite a bit of prototype efforts going on to harness this 5G towards the mission partner. And so from the commercial aspect of it, I mean, what's different is like, I mean, of course, they offer all these speeds, but to actually provide faster speeds, there has to be some changes on the spectrum issues. I mean, how do we actually push so much bandwidth on that side for that? So for that, we are relying on RF frequencies. I mean, going higher and higher on the frequencies and being able to aggregate all those frequencies on millimeter waves. So with that, it will be a different kind of infrastructure where we actually have to deploy quite a bit of base stations closer to each other and create some kind of a carrier aggregation to actually push this kind of a high-speed bandwidth on the end user. But of course, I mean, if you swing towards the Hessian partner, there's quite a bit of work going on the side link where your devices can actually talk to another device without the use of the base station. So there are advanced capability which we are trying to actually harness within DoD-CIO and see how this can actually be effective on our side.
So I'm gonna throw you a little bit of a curveball.
Sure.
Can you tell the audience about the way that we are approaching the problem, dividing it up, right, between the RAN, the core, the common services layers, and what we're looking for as we go out and we start to take advantage of the technology?
Okay, so there has been quite a bit of talk as far as, I mean, what can DoD do from the perspective of the core and the RAN, and these are actually all the core element pieces of the 5G infrastructure. The main piece, I just want to let you know about the 5G infrastructure is the core, where it's actually the brains of it, where it does all the compute power, where it does all the mobility function of it, the authentication and all that. And on the other end of the spectrum of the 5G infrastructure is the RAN, which is actually the radio access network. It used to be called the BTS. It was very simple in the old days when you just had the tower and you just had the radio, and all this intelligence was actually pushed towards the core. But with 5G, quite a bit of intelligence has been for the radio part of it. It's called now the RAN, has been pushed towards the RAN on that side. So once we have this infrastructure, so how do we actually take advantage of all that? So within the DoD, I mean, there's quite a bit of push that how about if the DoD mission partner just operates the RAN and there are some spectrum issues that has to be also managed at the end. So if DISA can play actually a key role in this, I mean, how do we connect all these RANs together at different bases? There's one at the Hill Air Force Base and there's one at Albany as well. So there's quite a bit of effort going on the smart warehousing, IoTs and all that. So DISA can play a very good role that if we connect all these disparate RANs and provide some kind of an interoperability with DISA hosting this core capability. So we are working on this architecture. I think I've also showed it to Steve and DISA director. So we're trying to promote this architecture where DISA plays a key role in providing the core capability and let the RAN be hosted at the mission partner side. So this would give them the advanced capability, and this would also give them interoperability and roaming capability that they can talk to each other whenever they roam between different RANs, and also provide some kind of connectivity to the commercial side as well.
So the breakdown there is really important for the direction that we see the agency and the way that we're going to be supporting the department going forward. So the more traditional DISA, the enterprise service provider for the department, that's where the core function comes in, right?
Yes, sir.
And that's where we start to, plug the core in to the transport layer that folks like Laura's team provide us. So that plugs into that backhaul capability, right? But as we take on more in the fourth estate work, from the commodity IT support perspective, potentially other elements of the department, that's where the RAN side starts to become interesting. And so we're approaching it from certainly two different perspectives. The core is, well, frankly, the core of it all, but then we see the RAN, just like, the way that we manage Wi-Fi access points in buildings today, in the places that we support, we would see ourselves supporting the RAN as well.
Correct, sir. So, I mean, if you see at the core of 5G, I mean, 5G core itself is quite capable. It also supports non-3GPP standards. I mean, it can also support Wi-Fi access points and all that. So it would actually give DISA the advantage of providing a campus-based 5G enterprise services. Not only that we are providing 5G services with the 5G RAN, but we can also provide some kind of service with the Wi-Fi access point as well. And this can all be interconnected on quite a bit of a large scale that DISA can play a very active role, that interconnecting different agencies with our core and providing all the 5G intelligence on our side.
All right, thanks. So with that, we've got a little bit of time left for some questions. So we'd like to open the floor. Questions, please come to the microphone if you have any. Don't all look at each other. Somebody wants to ask something. Go ahead, Johnson. Open it up.
Softball question here. How come I don't see SIPRNet version 2 here?
It's classified.
Right. So there's
It's classified.
yeah, it's classified. It's so
Short answer.
there is the what Johnson's referring to is there is some work right now going on to look at how we can reimagine the way that we do some things on SIPRNet. Right. The director stood in there this morning and talked a bit about the single tenant capability in IL6. If you really step back and look at it, that creates a whole new set of opportunities for the department to act as one department, right? We don't fight wars anymore as the Army, as the Air Force, as the Marine Corps. We fight wars as a department. We fight wars as combatant commands. And from an IT perspective, we need to start to follow that same model. And so SIPR 2 is starting to look at that. How do we fold in things like JADC2, Thunderdome, ICAM, all these programs and really start to take advantage of it on our warfighting network. So yes, it doesn't exist there, but it exists in
our hearts.
In our hearts. Yeah, there you go. Yes, sir.
Thanks, Deepak, you mentioned earlier an AI approach to incident detection and response, and I wonder if you could talk briefly about what data you still need that you don't currently have to do that better, and if you're concerned at all about different companies like Reddit and Twitter, et cetera, shutting down their API data so that there's actually less data to train GPTs on.
So for XDR, we're primarily looking at the data that's currently in our BDP, that's currently captured on the network, that's currently captured on the perimeter, that's currently on the endpoint, taking all that telemetry data, taking a holistic approach of that data, and then having an AI model help predict or process all that, and then give us some information that it would take a human a lot longer to do. So we're right now trying to see, again, just looking at what's out there, what can we do with what we have? Hope that answers your question.
Yes, sir.
So I see here on the graphs the encrypted traffic analysis, and I wanted to know if you do any work on encrypted search or encrypted machine learning and privacy technologies.
Okay.
Well, so I think frankly, some of the engagements that we've done with enterprise or encrypted traffic analysis and working with encrypted data over the last couple of years, we haven't seen as much movement in that space as we've kind of expected or hoped, right? Our concern there has been with the proliferation of TLS 1.3 and certificate pinning and things like that, that it was going to make it difficult for us to break and inspect traffic the way we've done it traditionally, right? So we wanted to see, what kind of information can we glean from encrypted data, without actually breaking and inspecting it. And frankly, we've talked to vendors over the last couple of years and just haven't seen the level of capability that we were hoping for there. So if there are newer capabilities out there, we would love to hear about them and discuss them.
Yeah, here's your chance, folks. Encrypted traffic analysis is on the bubble. You can either vote it on the island or off the island, but we're not getting a lot of traction there. So the next time you see this, it may or may not be on the list anymore. What else we got? Yes, sir.
Hey, David Zant. Thank you for doing this. I've got a question around generative AI and the role of this directorate as well as this in this role across the we'd love to know, how you envision the role. Do you see yourselves as one to demonstrate the use case, then expand it out, or provide a set of algorithms or a set of training or data? Love to get your thoughts.
Sure. You want to take a crack and then I can follow?
Yeah. So there are a couple of ways of looking at it. So this technology is fast evolving, right? It's only been around, a couple of months, right? So I've got my thoughts on there. Couple of ways we can look at it. So one is, can we use the large language models that, in industries generated, and there's a lots of value to it. So if any other organization, not even just us, were to do, to build their own large language model, it would take, sufficient compute resources, sufficient data, and to be able to do that. So to the extent possible, if a commercial large language model is available, and there are many out there, we want to look at what are some of their limitations, how do they perform, how do they behave. And then secondly, there's also the option available to fine-tune these. So if using transfer learning, so if for example, if there's some domain-specific information that these models are not familiar with, what's the ability to fine-tune them and train them? And then there's been lots of articles in the press about different companies, let's say fine-tuning or retraining large language models with their own specific proprietary data set. So something like that is also appealing to us. How can we take the existing model, augment it with our own information, and then finally would love to get industry's perspective. If for whatever reason we were to decide to build our own model in the department, or in the agency with the data that we have, is that something we're able to do? I don't know the answer to that. I mean, I think it's something that we're, at least I would like to investigate the possibility. But, like I said, this is, a very fast-moving space, and I think after some, more analysis and hearing from industry partners, I'd be able to better, answer the third part of the question.
Yeah, and there's two sides to the coin on this one, right? There's how do we get the agency to take better advantage of it? The department clearly has the JAIC, and they have the role of artificial intelligence writ large for the department. But there's the element of how does DISA take advantage of it, and what we're seeing is integration in a number of places. We see it as a force multiplier, right? Can we take that analyst and better equip that analyst with a generative AI element that helps them more quickly react or not have to sift through as much garbage, be able to write rules on the fly, that sort of thing. We've seen some interesting Office integrations from third parties for things like chatbots to say, hey, how do I get a new laptop? How do I do this? How do I do that? Right? To relieve some of the bureaucracy off of the user base. There's a whole host of good uses. But also the way that General Skinner talked about it as, it's also a force multiplier for the folks looking to do us harm. And the script kiddies sitting in their parents' basements that were once just one script kiddie, now multiply that, right? And now we've got to deal with the threat that comes along with that. So how do we recognize, right? The same way that you hear about teachers and the ability for them to fingerprint kids' papers. I remember sitting with one of my daughters, it was over Christmas break, and it was just, the generative AI thing was just starting to take off. And she was talking about how many of her friends are using it to help them write papers and that sort of thing. Of course, she'd never do such a thing, but all of her friends certainly are. But teachers are now able to fingerprint whether text came from a generative AI engine. So how do we start to fingerprint attacks and look for that capability as it's headed inbound? So there's really two sides. How do we leverage it to empower the workforce, but then at the same time leverage it to help us better defend the DODN and better equip the team at JFHQ DODN to defend the network. Any other questions? Yes, sir.
I see there's a lot of requirements. I'm just wondering, if you guys looked at overall, change management, getting the compliance right in the first place, and the whole, challenge that goes along with it. Any thoughts around managing overall, the requirements and change management sets?
No, we like to live dangerously. So yeah, the requirements process and change management is always a challenge, right? We are, as General Skinner mentioned, Mr. Barnhurst has been charged with how do we revise the processes within the agency so that when something hot pops up, we're able to get it in, get it through, is there a need for it, and move it along, versus going through endless bureaucratic boards and slowing down the delivery of capabilities. So there's a lot of desire to improve the way that we do our requirements processing and adhere to those. Change management, I don't know if any of you guys have got any opinions on that. There's also a recognition, we do not have a cohesive change management process or a strong enough change management process in many different sides of the agency. And with one is, all the way from, looking at the OSI model, providing services all the way from 1 to 7, a change at 1 can dramatically impact 2 through 7, right? So how do you understand that every change that you make actually can have a domino effect elsewhere and avoid making those changes? So we have some ideas in that space, but I think we're pretty early on. It's not an easy nut to crack. So
what about time requirements to compliance and making sure that all of those vulnerabilities are addressed and the different agencies are complying to it?
Yes. I don't have a strong answer for you. In terms of, are you talking about necessarily, because one of the things I think the department can do better about is that mindset of checklist compliance, right? I've done this, I've enabled this bit, I've enabled that bit, so I'm secure, versus more of an active role in ensuring you are continuously actually secure versus just coming off of a checklist. So I think we're in a transition period of moving from that and that ability to address those threats versus a STIG. They put us next to the bowling alley. All right. We're starting to run up on time. Yes, sir.
Eric, you looked lonely during the question and answer. So with API security, we've seen a lot of time, effort, and products that scan for vulnerabilities in APIs themselves.
Right.
But more and more, what we're seeing are actually authenticated attacks against APIs, where credentials along with static component credentials and so on. So what are some capabilities you're seeing to mitigate that attack?
Yeah, so, what we talked about earlier, we definitely, from the scanning the applications, being able to detect, what APIs are available, what's the mechanism which to interface with them. But then two, from more of a transmission perspective, being able to proxy those communications, be able to look at, see, what's sort of underneath the covers, where we can authenticate, be able to inspect to see what kind of vulnerabilities may exist as we're communicating to the actual application. Those are sort of the capabilities that we're looking for, relative to the whole set of security around APIs, if that makes sense to you. Yep.
All right, last call, because I'm going to get the hook otherwise. All right, so thank you all. Thanks to our panel here. Thank you all for coming out, and we appreciate your time. Thanks.